what I'm going to need to do is I'm going to need to draw a quad that looks kind of like this, right? It's got to be a 2D quad. It's got to have a height and a width relative to the camera. So what we need to do is we need to find out what those directions are. Well, what we certainly have to work with is we have the forward direction of this point and the forward direction of that point. Now, if we average those, we're going to have a forward direction of the 2 points, and this is really helpful. If they were off to the side, then it will be a more accurate direction. Instead of saying just camera dot forward. Okay, once we have the forward direction, we need to get the right direction. Well, the right direction is relatively easy because it's just the direction from one point to the other, which would be, if this is point 2, this is point 1, it would be 2 dot position, 2 dot pos, I'm running out of room, minus 1 dot pos. Okay, so that's how we can get the direction from one to the other. So we have the right and we have the forward. Once we have those, we take what we call a cross product. In other words, it's probably better just to use my hands. If you have the forward direction, you have the forward direction. Have the forward direction. You have the right direction, like that. Anyway, you get the idea. You can get the up direction. As in, cross product is if you have two directions, it's the one that's going that way. There we go. I use my hands. It's a bit more easy to see. So from the forward and the right, we can get the up. In other words, that's what we're doing here. So we're saying forward 1. Okay, direction forward is the average of forward 1 and forward 2. And then direction right is whatever the second one is minus the first one. And then our direction up is the cross product. And I just like to normalize it to know that we're working with absolute right and absolute up values. Okay, now let's have a look at what this screen scale is doing. This is where it gets interesting. This screen scale is like a humble little line, which is a little bit more interesting in the utility function in the utility class. But this is what makes the shader very special, and the reason is that no matter how far away the stars are, the line is, it'll render at the same width, at a consistent width. In other words, if you have a star let's say the camera's here, you have a star here and a star here, it's going to say, I'm going to render it at a width of this much here, and because this one's so far away, and we have the, the further away something is, the smaller it looks, I'm going to account for that and make it a little bit smaller. So in real life, the line looks like that, but to the camera, it looks like it's the same width. So let's have a look at how that's done. So screen scale. Get the screen scale for each of the points. Okay, get screen scale. So first of all, we're jumping into pixel scale. Well, what's that? That's saying how far away is this object, and this is where I'm going a little bit out of my realm because it's a little bit matrixy. And this, in fact, this entire function is a function that I've copied and pasted from somewhere on the internet, and I can't remember where I found it. Otherwise, I'd leave a link to it. But this is the magic. This is where it says, if it's really far away, then the meters per pixel, how big I'm going to draw it, will be much bigger. If it's really close, it'll be much smaller. So it's going to adjust accordingly. Now, the thing is that once we start deploying to, and anyway, it works in pixels. Once we start deploying to mobiles, things are going to start looking really goofy if we keep using pixels because of pixel density, different monitors. Like you do something on 4K will look completely different to something in, I don't know, on a 1080p monitor. So what we're going to do is we're going to adjust for that by saying, where instead of using pixel scale, which will vary, we're going to use screen width. So we're saying it's going to be some fraction of the screen width. If we passed in a fraction of 1, then that would be 100% of the screen width. Or